Okay, mayong adlaw class. We'll continue with our discussion on this course, Computational Physics 2, Numerical Introduction to Numerical Analysis in Physics. So this is the last topic on our first half sa midterm. So we're done with intro to MATLAB. So tulo lang jud ka topic for midterm no gamay ra. So you have intro to MATLAB, you are done with that. And then we also talk about during our last lecture video on finding roots of a certain function, finding the solution or the zeros of the function. And then this one is about function approximation and curve fitting. So we'll be talking about this and we will have a full understanding on what do we mean by function approximation that is applied on curve fitting. So we will be dealing more about this on data. Okay. So the goal of this chapter or this lecture video is to apply the method of curve fitting in approximating a function, specifically the method of least squares. So we'll know about this later. Then employ the method of least squares fitting for non-polynomial functions. And lastly, the easiest can will employ the MATLAB's built-in routine for curve fitting. So the most convenient is here. So, but before we'll introduce the MATLAB's built-in routine, we really have to know how that particular function is implemented. Okay, the mathematics behind it and the science behind it, so that we will not just blindly use that one without knowing nganong kana siya nga function will actually work. Okay. So there are actually a lot of problems in this uh, a lot of problems that we can think about and probably problems nga wala pa na-encounter and then we will solve. So many of those problems, physical problems such as data science. So we'll be talking about data science. So let's say problems in data science and also we have problems in experimental, right? And we also have problems in other under the experimental science, we have problems in physics, we have biology, chemistry, and so on. And these problems, especially kani sa mga experimental nga mga science, when you do experiments, you're actually producing also data sa imuhang experiment, right? Could be any data. Experiment mo og let's say measuring the velocity, measuring the time required for and so on. So you produce data points. And that requires or involve fitting to a certain curve. Okay. If you have the data, then your task is to capture. Okay. You are interested with the data and you are interested to capture the behavior of these data points if it obeys a certain theoretical or mathematical equation. Because in that way, we can do prediction and forecasting based on the model. So if you have your data, so it's important for you nga unsa kay equation nga mag-describe ani nga data. Let's say you want to say imong data is rainfall, it could be temperature. Then from that data, you want to make a forecast, okay, or prediction sa kahay possible nga mga temperature or rainfall or amount of rainfall in the next 2 weeks or 1 month or so. So modeling or doing mathematical modeling sa imuhang data would be important and useful. So we can do the simplest, which is the curve fitting. And in curve fitting, the simplest one is actually a straight line, okay? The simplest model. For example, take a look at this data, kaning picture, right? Sa picture is you have your data with you have a time and velocity. For each time, na kay velocity. So, record niya, right? This is experimental data, and then this is plotted on the time and velocity axis. So, if you have this data, so the simplest line or curve that you can fit for this data is actually a line. Okay? Let's draw a line. Let's say mo na akong line. Right? So for that particular line, so for that particular line, we can get unsa kahay equation ana nga line. So in that way, if you have an equation, you can actually make forecast dayon if you have your equation with you. So the primary goal is selecting and determining the best fit. So it could be nga yes line siya pero unsa man nga klase nga line. It could be kani siya ba nga kanibang nga line or usa kayang slope o yang y-intercept. So kaya na siya importante. So ang line is ana una di ba y equals mx plus b. This is the general equation of a line. So unsa ka na siya nga equation? Unsa kahay slope? Unsa kahay y-intercept? Given these points, usa kahay best fit given the empirical data. So we can actually do that by employing the method of least squares. Okay, so that's by far the most widely used mathematical curve fitting. So the method of least squares, requires that the sum of the squares of the vertical deviations of the experimental data from the curve data be minimum. Okay, what I'm saying is that para best ni siya nga fit, so we want nga best na siya nga fit. So this is best fit. To make that best fit, kailangan nga ang deviation niya from this line is minimum. Let's say, this line minus kaninga point. So, imo siyang i-minus. So, it's like summing the error ba? This is your best fit. So, for each point in line, i-minus nimo siya sa point sa data. Like, kanipod i-minus nimo sa kanang point, kaninga data, kana minus diha, and so on. So, each point na siya i-minus, right? I-minus nimo ang point sa line o kaning point diri sa data. Okay? It's like point sa line minus point sa data. I-minus nimo na siya, then you take the square kay para wala siya negative, puros positive. Kaya pwede man nga kung negative din siya kung dako ang data. It's either sa ubos o sa taas, right? And then you sum that one, then you get your sum of error. So the idea is kana. And i-make sure naman sa method of least squares in such a way nga ang kaning sum, it could be depende sa imong point sa line, wala lahi ang imuhang kaning result ani. So dapat ang result ana is minimum. So the idea is finding the sum of this entity nga dapat minimum siya. Okay? So diha na nimo pangitaon mo. So mo minimum siya if depende siya kung unsa ang imong equation sa line. So generally basically that's the idea of methods of least squares. So method of least squares po mo apply po siya sa mga uban curve, not only lines. Pwede siya mag least square ka sa parabolic or any kind of curve aside from straight line. But for now, we'll start simple, which is a straight line. So to understand what I mean, para mas masabtan siya nga concept, we'll have an example on a free fall experiment. Like mo na siya ang data sa free fall nga experiment. Parang nasa picture. So in this case, an object is dropped at a certain height sa free fall. I think ka-experiment na mo ani sa during your high school, measuring gravity, right? Measuring the acceleration due to gravity through free fall. So if you have an object drop at a certain height, the velocity of the object at each point in time is, let's say, recorded. Okay? So ang mas ano lang ni siya, mas precise ba kay at each point in time gi-measure siya. Usually katong experiment nato sa high school or first year college is mag-measure mo sa time gikan sa top padulong sa bottom, right? Pag drop sa object, start the time, tapos na po another person na sa ubos, mag-time, i-stop niya ang time pag abot sa ubos, okay? So that's how you do the measurement. But for this case, precise siya, let's say sensor gini siya kada point. So at 0.1 second na siya velocity, at 0.2 second, so on. So each point in time, a velocity is recorded. So we then now have a two-column data containing the time. Tara, so natin two-column. You have this one time, and then the velocity. Okay, this is column 1, and this is column 2. Okay, draw. Blue. So this is column 1. This is column 1. This is column 2. Right? And if you draw a straight line, your goal is actually to determine this best fit. Okay? Let's draw a straight line. Uy. Like that. Okay? So from this straight line, mo din na siyang pangitaon ang iyang least square nga minimum sa iyang sum sa error. Okay? So from the data, we have your time and velocity. So this is your x-axis, and this is your y-axis. Okay? So from this we can infer nga ang from this data we can infer the constant the constant acceleration due to gravity. So we need to find kung unsan ang equation ana, right? And equation sa line is kanina naman y equals mx plus b. Now for this case, y is velocity, right? And let's say ang slope nimo is a, or let's say you have generally you have this, the same gyapon na siya mx plus b, right? Tara. So this is your y-intercept. This is your slope. So this is familiar, right? Okay, sa mechanics man siya. Sa mechanics nga equation. So you can review your mechanics. So you have your equation sa line, and then we have to determine kung unsa in particular ang value sa imong A and value sa B. So we have to determine the value of A and B in such a way nga ang iyang sum sa error niya is minimum. Okay? So how do we do that? So, well, we'll have to do this in mathematical sense. Say na ako is sum or katong method of least square, katong sum sa error. And it's given by this. So, ang difference sa katong, this is the, oh, so this is the theoretical minus the data. So, kuhaan mo siya, take the difference and then you square. So, this is the katong equation sa line. And this is sa katong data. So, it's important nga we need to determine this one in such a way nga ang iyang sum is kana, it should be minimum. So our goal is to make this sum of error as small as it can be. Hence, hence the terminology least square. So that's why gitawag siya least square fit. Okay. So we can actually write this equation, this one, in terms of parameters A and B. Okay, so we have ang imong V of T of I is just A plus B T of I. Mao na, di ba? Equation sa line. Then square. Now, to make this minimum, we have to make this minimum ang iyang sum of squares. We have to take the derivative, right? Nakaagi naman siguro mo ani, kasi this is maxima minima nga problem. Maxima minima nga concept. So we have to evaluate the derivative of this function s with respect to a, and dapat 0 na siya. Okay? Okay, it's like this. Kasi ang curve nimo sa imuhang, this is your curve. Where do you think is the minimum? If the derivative niya or maximum, let's say, ano lang. We have this function. So, na duha ka case nga ang imong function is mag-minimum or mag-maximum. Ang iyang derivative dapat is 0. So, ang derivative sa, this is the function s. Ang derivative niya with respect to, let's say, x, this is x, this is s, is 0, meaning ang iyang slope is flat. And where can you find nga ang slope of a line is flat is kanina din. Right? So this is minimum. And this is maximum. So having this function, we can ensure nga ma-minimize nimo ang s. So ma-determine nimo ang a. So unsa dapat ang a nga this function is 0. So we'll evaluate that one. And also for the other case, b equals 0 because we need to find these constants a and b. Okay, to do that, we have partial of s with respect to a derivative. So this is partial. I don't know if kaagi na, I hope na kaagi na mo ani. Partial is like because duha man siya ka function of a and b. So it's like taking the derivative of a first. So if you have this partial derivative of s with respect to a, ang imong giderive is ang a lang, ang b is constant there. And if you take the partial derivative of s with respect to b, ang a na pod ang constant, b is changing. So let's do first the partial of s with respect to a. So taking the derivative of this one, applying the derivative rule, so we have 2 times a plus b ti minus b sub I. Then derivative sa sulod, derivative sa s with respect to a. Okay, ang derivative sa sulod is just 1, right? 1. 0 naman eh. Okay, wala man na siya a. Only a naman atong i-derive, so just 1. That's it. and this is equated to 0. So this is actually minimum. Kaya siya, minimum na siya. It's not maximum because when you take the derivative of that, second derivative, the second derivative will tell you the curvature. And if you take the second derivative of this with respect to a, it will give you a number which is greater than 0. And if you have a second derivative greater than 0, ang result is actually a minimum. So naa siya dire. Okay? Naa siya sa ubos. It's a minimum. Then, we do the same for b. Right? So for b, we have kanig hapon a plus b t sub I minus b sub I. And derivative with respect to b, so 0 na siya. Kanipod 0 na siya. But this one, with respect to b, mabili na lang is t sub I. And this is equated to 0. Okay? So collecting all this one, ato i-collect ni, so atong i-write ni siya, we actually have this plus bt sub I minus pi equals 0, and ang isa is a plus, ako nang gi-drop ang 2. Okay, anyway, 0 ma-drop ni ma-divide ni mo ang whole equation over 2. So wala na mga 2. This is actually a times t sub I kani plus b t sub I square minus vi t sub I. That's equal to 0. Okay? So further, we can simplify this. Gani. So this is I from 1 up to n. So ang summation diri sa A, summation anak from 1 up to n, it's actually n. We have an plus b tapos i-transfer na ko sa pikas ang gani. And then for the other case, we have t sub I square, I runs from 1 up to n equals gani, v sub I times t sub I runs from 1 up to n. So we have this equation, two sets of equation. So balik sa atong goal. Atong goal is to determine the line, right? The best fit. And in order for us to determine the line, we need to determine the constants a and b. Okay, mao man ni ang equation sa line, right? This one, that one. So we need to determine the constants a and b in such a way ang iyang sum sa squares is a minimum, least. Okay? That way makakuha ta og best fit. Now, how do you solve this one? Okay? Because if a and b are determined while holding the keeping our determining a and b while holding the equations true, tapos minimum dapat ang error or katong sum of squares. So solving these two equations, we can do it by elimination process, or easier than that is the idea of matrix. Okay, so we can transform this into matrix by having this. ang mga coefficients atong ipang butang. So we have n summation of t sub I. Ang kaning mga a and b sa isa na siya ka matrix, lahi na siya ka matrix. So atong i-consider is kanilang n, this one, and this. So we have summation t sub I, right? And then summation t sub I square. So tanda na siya, I runs from 1 up to n, I runs from 1 up to n. Okay, and then this one is A and B. Okay, so mas neat ni siya tanawon. And then sa right hand side, of course, we have the summations of V sub I and summations of V sub I, T sub I. I runs from 1 up to n. From 1 up to n. So these two are equivalent, kaning nga equation o kaning nga equation. Kaya sa law sa matrix, kay anak naman na siya. So, kanin siya is ma-reproduce na nimo, the same. You have kanin siya times kana times kana equals this. We have the first equation. Sunod na po, kani times kana, right? Kani na po times kana, you have the second equation. You have the second equation. So actually, they're actually the same. Okay? So the reason why we have this matrix, kay masayon mo na siya isolve sa MATLAB. Okay? Ang idea naman ani is, ma-simplify ni siya kanina equation. Imo na to ni siyang, so let's say generally you have an, let's say M matrix. You have matrix M times this vector equals any constant, right? Let's say constant C. So in this case, ang M nimo is kani. This is the M. Ang X nimo is kana. Ang C is kani. Okay? So ato ang goal is i-determine ang constants A and B, right? Where it corresponds to X. So to do that, we have X should be like M inverse C. Or sa MATLAB nga environment, it's just M over C. So kana siyang it's like backslash. Okay? So if you have this sa MATLAB, ma-determine din mo ang X, unsa ang A, unsa ang B. Imo man ni ang X, A and B. So this is a 2 by 2 matrix. This is a 2 by 1 matrix. This is a 2 by 1. Or this is just a column. Right? Column. Column po ni. Column vector. Column matrix. So we can do that in MATLAB. Let's open up MATLAB. Okay, I have here open ang MATLAB. And then, of course, we need the data, of course, to determine our best fit sa ito ang line. So ang data is mao ni, di ba? Itong kani siya naa sa ito ang kani. So ako na siyang gibuhatan og points in X from 0 to 1 with an increment of 0.1. Then ang velocity is I manually encode it. So this is just call this a row. It should be a column vector. So for this case, ako na siyang gi-row. Okay. We have 0.1 and so on. Okay. Pasabot naman ani is continuation sa kani. So kani siya isumpay na siya. Okay. If taas na kay inyong equation ba na di mo gusto nga maabot siya og say na na siyang putlo. Okay? So first, take a look at the equation. Kani man ang atong i-determine, right? So we need to set up o atong ibutang daan ang mga matrices. We have M nga matrix, ang X nga matrix, ug unsa ang C nga matrix. And notice nga natay n, ato na nang ipangbutang diha ang sum. So, we'll determine first n, just actually the length of, just the length of t or the length of v, the same na siya. Okay? And then we'll determine m. So, sa inyohang m is, if, naon. Okay. Para mas klaro siya. Right? Tara. So, your M matrix is kani. You have n summation of ti and so on. So, pwede ta mag-ingon ani. You have n, right? Sunod, comma, sum of t, right? And then semicolon, next nga row, you have sum of t gihapon, comma, and then sum of ti, right? So ang imong t is matrix man na siya or row vector. So kailangan siya mag-element wise, meaning square kada usa before nimo siya isum. So you have t dot square, right? So that's your matrix M. Sunod, your matrix C. So your matrix C is katong constant naman ni siya. So we have sum of V and then sum of V. So matrix kuan niya mo siya element wise na siya nga multiplication times T. So that would be your matrix C. And then we can now solve for this one, X. So we can solve for X. So we can solve for X, which is M backslash C. So in MATLAB, we can immediately do that in a straightforward manner. M C. So the result would be a 2 by 1 matrix. Okay? Ang result ana is a 2 by 1 matrix. Okay, ma-determine mo unsa ang X, unsa ang A and B. So we'll try to run this one. So X1. Okay. So atong matrix dimension is wala nag-agree. Let me see. Okay. So dapat for this case, oh, I cannot write. So ang error niya is dapat this is a column vector man, di ba? So dapat naka sa may column na siya. Okay. So let's run it again. Tara. So your x is ang iyang value sa x is you have your negative 0.0240 and ang b is 10.089. So this is for A and this is for B. Okay, that's how easy it is to determine the constants. Tara, this is XA and this is XB. So, na-determine na nato kung saan yung constants. So, in this case, na-solve na to, A and B naman na siya. Where A is negative 0.0240 and ang B is 10.0890. So once you have these constants, we've actually determined the equation of our line. Okay? So equation sa tong line, have A plus B t, where A is negative 0.0240 plus 10.0890 t. So notice na this is your B, this is your gravity, right? So somehow close siya sa kung unsa ang ihang true value sa imong gravity. Okay? So to be able to appreciate more of this, para mas ma-appreciate pa gyud nato kanato na obtain nga best fit, we'll have to plot both the numerical data, both the empirical data katong experiment nga data and the best fit into one graph para makakuha tagi kung ano nga graph. Okay? Nasa kanita po straight line. So how do we do that in MATLAB? We just have to add graphs to existing program. Okay, and to do that, we'll have this. Say this is my theoretical. So my theoretical is this is where I store my value x matrix maning x. It contains a and b, right? Katong constants. X of 1 is the first element, which is a. X of 2 is the second element, which is b. So a x of 1 plus b x of 2. Tapos this one. May element wise because kada element sa T multiplyan nimo og katong constant nga B. Okay? And then we'll plot. So plot first is katong data T and the B, right? Katong data. And then we'll have this, let's say dash line sa tapos color red. And then the second graph is katong theoretical. So we have T and VT. So what is VT? Mo ni siya. Itong with the determined factors, parameters A and B. Okay. And then we'll have this as black na color. Tapos straight line lang siya. So, okay. Then, pa-add sa beauty sa itong adding beauty sa ito ang graph. We have X label, time, Y label, Y label, velocity, then you have title, empirical and best fit, right? Empirical and best fit, best fit, right? Tapos, putang-putag legend. So the first graph is empirical and the second graph is the best fit. Okay, so this is empirical data. So ito na siya i-graph. Ito i-run. Okay, so this is the result. So because of what we did, katong siyang the method of least squares, we were able to determine the graph, okay, the best fit. So na-determine na to ang ang iyang parameters A and B. We were able to determine the equation of the best fit, the equation of the line, and then we superimpose it with the existing data. So in this way, kuha na din ka og kanang forecast, right? Using this equation nga usa ka ang possible nga value sa velocity with time greater than 1. Let's say at time t equals 5 seconds, usa kayang velocity and so on. Okay, so that's how you do uh, least square fitting. Okay, so this is part 1 sa atong discussion. So sa next video, we'll discuss on the general least square fitting. Okay, okay, we'll consider not just line. How about katong case nga parabolic na siya or other functions. Okay, still method sa least squares gihapon. Okay, that will be all and see you on the next video.